Welcome to comments about confidence intervals. So the main thing we're going to focus on here is different confidence levels. So far we've looked at 95% confidence. So far we've seen 95% confidence. But we can do this for other confidence levels as well. But we can find other confidence intervals as well. The only thing that changes is the margin of error calculation. So the only change is the margin of error calculation. So I'm going to give myself just a little more room. I apologize for the interruption. All right, so for 95% confidence, the formula for margin of error is 1.96 times sigma sub p hat times our standard error. Again, that was 95% of data in a normal distribution fall within 1.96 standard deviations of the mean. We can also do 90% confidence. For 90% confidence, our margin of error is 1.65 times the standard error. So 90% of data in a normal distribution fall within 1.65 copies of the standard deviation. And then for 99% confidence, the margin of error is 2.58 times the standard error, or sigma sub p hat. So 99% of data in a normal distribution, 99% of samples in the normal p hat distribution fall within 2.58 copies of the standard deviation of the mean. So this is the only step that differs when we do our confidence intervals. So if you look at the examples I've done previously, step 1 is still understanding the problem. Step 2, we're still justifying that the study was run well and we can find the confidence interval. Step 3, we're still understanding the p hat distribution. Step 4, we were supposed to find our confidence interval. So it is still, the base is still our p hat. The margin of error calculation now changes depending on the confidence level, but then finding the confidence interval is the same, and our sentence is the same idea. We just change our confidence level in the sentence. The other thing we want to take a look at is just noting that we want to balance confidence level, which is our measure of accuracy, with interval width or precision. So essentially, confidence level, we're looking at how likely our process is to yield an accurate result. So this is how likely our research method is to yield an accurate or correct interval that actually contains the true population proportion. versus the interval width tells us how precise our answer is. It's not very informative if we have a very wide interval. A narrow interval is much more informative, right? So a narrow interval is much more informative but less likely to be accurate. We're not giving ourselves as much room for error if we have a narrow interval. So our goal is to have high confidence level paired with a narrow interval. So we have both high chance for accuracy and strong precision. So our goal is we want to be both accurate and precise. So in order to do that, we want to have a high confidence level. So use a high confidence level to increase accuracy. And then if we want to increase precision, make a narrower interval, then what we want to do is use large samples. So remember that when we use larger samples, the standard deviation of the p-hat distribution gets smaller. So what we can do is we can use a large sample to increase precision. Or to narrow the interval. So usually we see 95% confidence intervals. Sometimes you want to have a higher chance of being accurate, so you'll use a 99% confidence interval. Sometimes it's not a huge deal if it's not accurate, and so then you might use a 90% confidence interval. I don't think I've ever seen someone use something below 90% confidence. And then while we don't necessarily need to use a large sample to guarantee normality, the larger the sample we use, the smaller the standard deviation and the narrower our intervals will be. So the reason researchers often use larger samples is so that their results are more precise. So those are just my comments about confidence intervals in general.